Hi everyone. Recently I've been experimenting with foggy scenes and I realized that Unity and Unreal Fog seem to be missing one key feature. They don't blur the scene. I realized this while experimenting with some Minecraft shaders. As you can see, the fog in the swamp makes everything look so misty. This effect is even more obvious in the Nether. You can even notice it in water. It's really amazing and I wonder why a lot of games don't do it. When we go back to Unreal and turn up the fog, we can see that the effect is completely missing. Same for Unity. Let's fix that. As per usual, you can download the files for free on my donation page. These resources will always be free, but a donation is always appreciated. Before we jump into the shader graph, let's understand why this happens. Fog is made out of tiny water droplets. When a light ray hits those droplets, it scatters. That scattering is why distant objects lose sharpness. The deeper an object is in the fog, the blurrier its appearance. This effect sounds a lot like depth of field. We can definitely fake the effect like this very easily, but it comes with some limitations. The effect will be global, so we cannot combine it with local fog volumes. And since the effect is more of a hack, you won't be able to have depth of field as that effect is already being used. In Unreal Engine, Gaussian depth of field was removed from post-processing, so you'll be forced to use the cinematic camera for this effect, which is very annoying. So if you want a quick and dirty solution, don't use depth of field in your project and don't care about local volumes. This will most likely work. Here's a quick comparison of how the effect looks. You can see that in both engines it immediately makes a big difference. It makes everything moodier. I want to spend a moment praising the games with this effect. The most notable, in my opinion, is Skyrim. They really nailed the overall atmosphere. Now let's jump into a slightly more complex implementation. The base of the effect will rely on a blur shader. I have decided to go for Gaussian because of its simple implementation. Gaussian blur is created by offsetting the scene image multiple times and combining it back together. The amount of times we offset the image by determines the quality of the blur. This is called the sample count. The distance between the samples makes the image look blurrier. This is called the blur radius. When combining the images, their opacity needs to add back to 1, restoring the original colors. To better visualize the technique, we can see what is happening to the sphere. With a low sample count, you can clearly see it duplicating as I increase the blur radius. The next thing we can do is adjust the intensity of the effect based on the distance. The further something is, the blurrier it will be. Doing this with post-processing will allow us to create interesting visuals. For example, we can use masks to control where the effect will be applied. Perfect for local fog. More on that later. And by the way, there's nothing stopping you from using this in other applications like Godot and Blender. I tested it myself, and as you can see, the results are exactly the same because the underlying math is the same. In Blender, there's even a dedicated Gaussian blur node in the compositor, which is more complex than what I will be working on, as it seems to dynamically add samples based on the blur amount. With all of this out of the way, let's start working on the graph. We can begin by creating our offsets. Think of these as vectors or directions in which our image will be offset to. Next, we have to get the size of 1 pixel by dividing 1 over our screen resolution. When we multiply this by each of the vectors, we get UV offsets that move us exactly whole pixels in X and Y. Then, we add these onto the UVs of the screen so that each sample moves to a nearby pixel. And finally, we combine everything together with a weighted average. Each sample is given an importance. When everything is added back together, it must sum up to 1, otherwise the brightness of our scene will be different. We can multiply our offsets by a float to easily control their intensity. For example, if we multiply the offsets by 10, the samples will be 10 times as distant, hence blurrier. Now that our blur works, we need to change its size based on the distance. That's really simple. All we have to do is take the scene depth and divide it by an arbitrary number like 10,000. We can multiply our result by a float, which will allow us to control the distance of the effect more finely. Then we need to saturate to clamp it in a 0 to 1 range. If we check the scene depth, we can see that the objects close to us are black and the objects far away from us are white. The idea is to multiply the offsets we created with this depth, so that the distance between the samples increases as the pixels are further away from us. Since Unreal provides built-in nodes for the samples, I have gone ahead and cleaned up the node graph a little. This is what it looks like. Feel free to copy it. Perfect. Now we have a blur effect that changes based on the distance. Unreal and Unity allow for post-processing effects to be masked based on custom channels that we can define. To only apply the blur on local fog, the idea is to mask out the areas where the density of the fog is sufficient. Unfortunately, I couldn't find a way to isolate the render pass of the volumetric fog in both engines. If anyone has an idea on how to do it, let me know in the comments. But for now, I opted for a simple workaround, which is creating fog masks and rendering them in custom depth passes. I won't cover custom depth passes in this tutorial because they work differently in different engines, but they're very simple to understand and I have linked some engine-specific tutorials. The fog mask itself is a simple animated texture with dithering applied to it. We want to make sure that this is a masked material and not a transparent one. The result will be quite noisy, but don't worry, it won't be a problem. The next step is to make sure the object is only rendered in the custom pass and not in the main pass. Then we can reference our stencil in the post-processing shader and use that as a mask. I have tinted the blur effect red to make it stand out better. The last step is to add these cards on top of our current local fog. There are some ways the effect will be improved, for example by using a particle system to spawn the fog cards, or making the mask a more complex 3D mesh. Regardless, I think a cleaner implementation would most likely require engine modifications. I wish some kind of stencil was provided out of the box, so we didn't have to create our own masks. I hope you enjoyed this video, and check out my donation page if you want to support me.